Hi, boys and girls. Sorry I can't be with you again. Yesterday, we started talking about how we can see the relationship between sets of ordered pairs and what happens when you have ordered pairs that have the same exact absolute value in both the x and y coordinates. And we left off with this point right here where you have an ordered pair where it's 3, 4, and another ordered pair which is -3, -4. Just want to remind you, yesterday when we plotted those points, we noticed that 3, 4 is in quadrant 1, where -3, -4 is in quadrant 3, and it appears to be that they are diagonal from each other. So we said they were similar because they were both 3 away from the y-axis and 4 away from the x-axis. However, they're different because the x and y coordinate were going in the opposite direction. So the last part we didn't get to is what's the relationship between the coordinate and location on the plane were. Yesterday we talked about the y-axis and the x-axis as being the line of symmetry in reflection. And in this case, you don't see the x-axis being a line of symmetry here and the y-axis being a line of symmetry. They're actually both reflecting both across the y-axis and the x-axis. So what I'm saying is, if I were to reflect this point and I want it to go here, I would have to reflect it twice. Once across the y-axis and again across the x-axis to get back to here. Or, it doesn't matter if I do the x and y-axis first. I could reflect across the x-axis first and then back across the y-axis to get a point diagonal from each other. When we have that, that's when the ordered pairs, the coordinates, are both opposite from each other. So, the reflection is across both the x and y axis. Okay, now you get to do the exercises, and hopefully the note can help you along the way. In each column, you need to write the coordinates of the points that are related to the given point by criteria listed in the first column of the table. Point S, 5, 3, has been reflected across over the x and y axes for you as a guide, and its images are shown in the coordinate plane. So we have point F, and they're showing that it has been reflected across both the x and y axes as a guide. Use a coordinate grid to help locate each point and its corresponding point. Okay, so again, S is being reflected across both the y-axis and the x-axis. So I'm going to do this column with you, and then you're going to use the rest. If you get stuck, just think about what I did over here in my model. So the given point is reflected across the x-axis. So we had the ordered pair 5, 3. If I were to reflect this across the x-axis, so here's my ordered pair 5, 3. I want to reflect it across the x-axis. So that means I need to count how far away it is from the x-axis. It's 3 away. So that means we're going to go down 3. Notice the value of x stays the same, my x-coordinate. So my x-coordinate will still be 5. It's my y-coordinate that changes. It's going to become its opposite. So when I reflect across the x-axis, x-coordinate remains the same, but the y becomes its opposite. Now I'm going to take the given point, 5, 3, and reflect that across the y-axis. So we're going to take this point, S again. We're going to go across the y-axis instead of x. So count how far it is from y. It's 5 away. So that means we're going to go 5 away to the left. Notice the y-coordinate doesn't change. It's still at 3. However, it's at -5, 3. So you can make the assumption that if you reflect across the y-axis, the y-coordinate remains the same. It's the x-coordinate that changes just opposite. Now, given the point is reflected first across the x-axis, so this point across the x-axis, and then we're going to take this point M and reflect it across the y-axis again. So M is 5 away. That means we need to count 5 away again. So notice where point A is. Point A is now at -5, -3. Notice the ordered pair now. When you do that to reflection, both coordinates changes to its opposite. So let's try that again. The given point, F, is reflected across the y-axis first, then across the x-axis. We're back to A again. So no matter which way you go, you're going to end up at point A. Again, two reflections mean both coordinate changes is opposite. So that should help you with these columns when you do this. Good luck!